So I have been playing around with applying clean architecture to my Next.js side project, and I wanted to kind of share with you the approach that I'm taking and also kind of share with you my folder structure, where I like to put files, where I like to have different shared libraries, etc. So right now, the application that I'm going to share with you is super simple. It's just a pantry tracking application where you can keep track of things that are in your pantry. So if I wanted to, for example, add some extra cheese that I went to the store and bought, I could do that. I can also go over here and just go ahead and update that and add 2. You can also remove things. So if I were to click minus here, that'll remove it and add it to the out of stock collection. So that when I go to the store, I can see that, hey, I'm out of eggs. Also, I was going to add a feature to basically add a running low. So I was going to make a button here or something that says like the ability to mark it as running low. That's honestly all I have right now. But I've been focusing more on the structure of the application and where certain modules should live, what should know about other modules, like what should be dependent on other modules, etc. So starting off, there's a Next.js application. Now, what I like to do in all my applications is I like to have a Docker Compose file where I define the database, right? In most of my applications, I try to use Postgres. If I'm planning to use PlanetScale, I'll just use a MySQL version of this Docker Compose. And what this allows me to do is when anyone wants to work on this project, all they need to do is do a Docker Compose up, and then they get a running database that the Next.js application can connect to. Now, the top level of the project is just a bunch of like configuration files and stuff like that. I mean, I'm using SST to potentially deploy this application. So I have like an SST config where I define like some cache policies and how to deploy the Next.js site. I haven't actually deployed this application anywhere yet, but I do plan to. I like to use GitHub Actions to deploy everything. So I typically have like a deploy YAML inside my project. And this is used for basically setting up some tasks that run automatically when I push to a particular branch or tag or release. In this case, when I push the main, it's going to go ahead and try to deploy my application. So it checks out my code, it sets up Node 18, it installs dependencies, and then it tries to run an SST deploy against my AWS environment, right? So inside GitHub Actions, I probably have environment variables set up that give us AWS secret access keys and tokens so that I can actually do a deployment from GitHub Actions. And that'll basically look at this file, build my Next.js application, and deploy it out, which is what this is right here. So that's more of the infrastructure side of things. Let's go ahead and look at the structure of my Next.js application. So inside my source directory, I'm using app router. So the way I like to do things is I've seen people make a components directory and they put like all their components that are related to pages inside this components directory. And then this is typically a slim directory that doesn't have much. The way I like to do it is if you have a page, then the thing that the page depends on should live right next to it as a file. Okay, so for example, if I go to my dashboard, everything that's related to the dashboard should be in this dashboard directory. So for example, I have the page here, but then if I were to need a client component, I would put that client component inside the same directory location, like I did here. Also this form. So I keep it close together as possible so that I don't have to go back and forth between this components directory and my actual dashboard page, right? I find this much easier to follow and understand because I can come into a new project and I can just open a folder and I know everything that's related to the dashboard will be right here. My rule of thumb is that nothing should be in this components directory unless it's used in multiple places. If you have a component that's in this component directory and it's only used in one place, that is a good signal that you should probably just put it either inside the component itself or in a file that's next to. Now, a second thing I like doing is I like to try to have it be one component per file. Now, if it's a component that's exported, for example, we have this items table. This item table only has a single component called items table that's exported. Now, if you have multiple subcomponents that this thing depends on, it's fine to put them inside of this file, like just don't export them. I would say if you have a file that has multiple exports in it, it's probably also a good signal to have multiple files. Now, that's just the way I like to do it. Now, if you can do that, if I can go through here and like comment out a component and half of the stuff up here turns red, that's a good sign that you could kind of decouple those components, right? One component has a bunch of dependencies that another one doesn't need. And I think that's a good sign of just moving it to a separate file. It helps me know when I look at a file that, okay, these things are all dependencies that are definitely needed by the items table. And that's kind of the approach I'm taking with the server actions, right? So I have a underscore actions folder, so it's not picked up by the URL in the router. And I create different files for all my actions. I was doing an actions file that had like multiple actions in it. But at some point, like the files were getting pretty long. Like you'd have one action that was completely unrelated to another action. Maybe it was importing some functionality that the other action didn't need. So I think just separating them out into separate actions just makes the code a little bit easier to read and understand. And I'll walk you through the whole clean architecture part of that in a bit. So I have a data access folder, and this data access folder is where I'm putting all of my functions that deal with data access, such as talking to the database, maybe talking to Postgres or Mongo or whatever database you're using. Now, as you can tell here, I'm actually putting multiple exports in the same directory. This is kind of like a repository approach, if you want to kind of follow that pattern. But I have basically every function that's dealing with Drizzle ORM is going to live in this items. And that's because I only have one items table, right? So the repository approach that a lot of people take is every table in the database typically has like a file that's associated with it. So I got an items table, and then that means I have an items repository that I can actually use. And inside of this file, you have like all your CRUD methods. Now, alongside that, I have a DB directory, which is where I have all my Drizzle stuff. This is just kind of following the documentation that they provide you with Drizzle. And then my schema stuff is here. And then I also have entities. So we'll talk about that in a bit. But these are like the domain entities or business entities, whatever you want to call it. But basically, this is what I'm using in my application to keep track of whatever logic might be necessary to validate what an item will look like. And also provide it some helper methods for kind of setting things and changing the entity over time. And I will dive into this in a little bit. This is more like in the lines of clean architecture. For the lib directory, I just put any type of third-party libraries. For example, I have like authentication here. I have utilities here. Basically, if you have any third-party libraries, like let's say you want to talk to AWS, you probably want an AWS TS file. So you can kind of like wrap those third-party libraries so that they're not like importing AWS all throughout your code base. It just becomes a lot harder to refactor down the road. And then I have a use cases directory. So use cases, again, I may split this up into separate files because it's starting to get a little bit unwieldy. But for the items, whenever someone wants to do something with items, such as create an item or remove an item, etc., I have these use cases that we call, which use the domain entities and then also use persistence methods that are coming from the data access directory to kind of do what needs to be done to increment an item, decrement an item, etc. Now we're going to dive into the whole clean architecture side of things. All right, so in my items table, I have a decrement items action, and let's go and see how this is actually used. So when I click on the minus button, this is just going to invoke the server action. All right, so how this decrement item action is working, and a lot of my actions kind of follow the same pattern, is if the action requires some type of authentication, I'll first get that. And then also I get the item ID from the form data. And then what I do is I call my use case. Okay. Now, one thing that you might find really weird is that I'm actually passing the dependencies of that use case inside of the function call. So the reason I'm doing this is because if you follow the guidelines of clean architecture, your use cases, which are sometimes called interactors, maybe you might call them controllers, they shouldn't know about various persistence level dependencies. They shouldn't know how to directly import this data access component. So other than this one, for some reason, I need to refactor this code a little bit. I don't have knowledge. These things don't have knowledge of the data access layer. These things are passed inside a context using dependency inversion. Again, so this action here, this thing is importing the persistence methods, the data access methods, and then I'm passing them in as needed to these use cases. And then the second argument is just the data that the use case needs. Now, typically you should keep this as primitives. Now, some of the reasons I'm doing this is, first of all, I want to insulate my server action from my business logic, right? I don't want any of my business logic or domain logic bleeding in to my front end, into my next application. I rather have that all separated, and I'm doing that via use cases. I'm also using DTOs, which I'll talk about later. But again, Next.js shouldn't really understand how to talk to a database directly. It should just call an abstraction that knows how to talk to a database and knows how to run your logic. So if we go back to decrement items use case, what this is doing is it's going to get the user from the context. Again, this use case doesn't know how to check if a user is authenticated, doesn't know how to check JWTs, it doesn't know how to check cookies. All it knows is that there's a method here that's passed to me that when I call it, I may potentially get a user object back. And if I don't, I can just throw an authentication error. So after we check if we're authenticated, what I do is I do a context.getItem. And if you look at the return type here, it's actually returning a promise of item DTO. Okay, so we don't know that we're contacting Postgres. We don't know that we're contacting a database. We don't know we're using Drizzle or Prisma. All this use case knows is that when I call this method, I get some type of data transfer object back from some location. This is one of the key parts that we'll keep hitting on with clean architecture, is that you're trying to insulate various layers of your application from other things. Okay? It just makes it easier to refactor down the road. At least that's what people claim. I kind of agree with it. I do think it gives your application some structure. But if you notice, I kind of have my own custom DTOs, and I use those DTOs and kind of convert what comes back from Prisma. So if you look over here, we're calling a get item method, which is down here. And the way this is work, it's using Drizzle to get an item from a database. And I'm converting that Drizzle thing to a DTO, right? So I pass the return object to this toDTO mapper, which basically takes in that Drizzle item and returns a custom data transfer object. Now this can seem a little redundant, but what this allows you to do is on the database side of things, if you ever decide to refactor or change keys or properties, for example, let's say quantity was actually going to be called like number of items. What this allows you to do is now your business logic doesn't have to change at all, right? It's just your database layer that is changing how stuff is formatted, but your use case is not affected because it just depends on a DTO, which has a certain format. So that's kind of the benefit. Again, you can argue this is overkill, this is over engineering, but this is what I've seen a lot in larger applications, dare I say enterprise applications, where they try to follow this pattern. So now we have a DTO, and I've actually seen people return entities from your persistence methods. Like you could potentially have get item not return a DTO, you could have it return an item entity, and you can do this mapping here. Like you could have this be like a new item if you wanted to. This is just the approach I like to take, and I think it works okay. So now that we have the DTO, I have an item entity, which takes in some generic primitives for constructing an item. So in our case, I'm passing in that DTO, and then we get back an item entity. So an item entity is much different from a DTO. It actually has a bunch of things on it, some methods on it that you can invoke as your business entities need to change. Now, this is a super simple example. Like, I mean, we're just keeping track of items, right? But in larger applications, your entities might have a ton of different properties, a bunch of different validation rules around those properties. For example, like you might have this need where certain properties depend on other properties to be certain values. So you'll have these helper methods that you call, which know how to update various things in sync, instead of just like manually changing all of them willy-nilly, right? So if you look up here, I'm trying to make all these things private. These are all private members. So my use case does not have access to actually change any of those underlying properties, right? Or those members of the class. I have to use getters and setters, and I also have to use helper methods if I want to change how this entity works. So let's move on from this, this line. Basically, after I create the entity, I'm using one of those getter methods to check to make sure that we have enough quantity for us to decrement, right? So if we have greater than or equal to 1, I'm going to go ahead and just set the quantity to -1. Now, I probably could have just added a decrement method to this entity, which does that logic. I mean, it's kind of a debate of where to put some of this business logic. Like, does this belong in the use case? Does it belong in the actual entities? I'm not too sure. In this case, maybe this is an entity thing, but regardless, at some point, when you're changing the entities, you want to actually validate them. Okay? You want to make sure that as these use cases are changing things, you're not potentially going to store bad entities into your database. So you do want to call like a validate method. In my case, I have a validate method, which basically just uses Zod to verify that the current state of this entity is all valid. In our case, we make sure that the name, at least has some length. We have a user ID attached to it. We have some quantity, which should be a minimum of 0. And we have a Boolean called isLow to verify that, hey, this is an actual Boolean and defaults to false. So after we validate that this item is all good, we can just update it using that update method that was passed in using dependency injection. And this is, again, going to take in a DTO. If you look at this method, this takes in a DTO. It doesn't take in the entity itself. It just takes in a object with some primitives on it, and it knows how to store this in the database. So if I go back here, I have a mapper which takes in an entity, and it converts it to the DTO that's needed. Okay? And it knows how to call these getter methods to kind of take the information from the entity and transfer it into a DTO, so that when I pass this to the persistence layer or the data access layer, the data access doesn't have access to that full entity. It just, again, takes a DTO. And then finally, I return the DTO to the front end. So that's kind of the approach that I've been taking. Again, you may look at this and say, holy moly, this is so much over engineering. And sometimes I go back and forth debating with myself of, is this over engineering? I have Next.js projects. So that was an example of mutating data. But also when you're fetching data, you should probably also use use cases here. I need to come through here and refactor this. I'm just accessing my data access layer directly here. Technically, if you're doing this properly, you should be actually invoking a use case here, which is going to invoke the data access layer, right? So you want to have some layered architecture in your backend. After explaining this, you might think to yourself, dude, this is over engineering. And if your project is small and your team is maybe 1 or 2 people, then yeah, this might be over engineering. What I've seen, even on the Community Code Racer project, is we had a bunch of people pushing code all the time, and it became very, very hard to verify a couple of things. First of all, it became very hard to verify that we're not leaking various things from our data. I think we actually had an instance where we had emails just being leaked out to everyone. So everyone who registered into the system, their emails were just apparent in the API call. So you could load up your Chrome network tab, you can look at the network requests and see everyone's email in the system who registered. And the reason that kind of happened is because we didn't have a data access layer. We were just kind of fetching items directly from the database using Prisma. And since it was a community project and a lot of people weren't really familiar with what they were doing, it's very easy for people to just accidentally return back the things that they shouldn't. Versus this approach, first of all, we have the data access layer, and we can actually use these DTOs to prevent certain things from even coming over the wire. Like for example, let's say this thing had some password or email on it. We could just not set it in the mapper. We just don't ever return that from the data access layer. And for whatever reason we do need it, we can make that very explicit in that data layer. Okay, same thing with the use case. We have another layer which allows us to basically create a DTO to basically prevent what gets sent back to the front end, right, to your Next.js application. So it's another line of defense, and it makes reviewing the code a lot easier, right? If I see a PR and there's no data access changes, I don't have to be on guard of like, oh, there might be a big security issue with this PR. Versus when I do see a PR that's making changes to data access and changing the DTOs, then I have to be a lot more thorough to make sure that, hey, maybe double check that nothing is getting leaked. Okay, organizing your code is a good thing. I think people like to just try to code as fast as possible and hack stuff together, but I do think there are benefits to following some of these older design patterns that a lot of people use, because I do think they have some good merits to them. Now, another good benefit of this is technically you can use a monorepo, and I can pull out some of this stuff and have it live in a completely separate project and kind of test it separately from this Next.js application, right? So the data access, the entities, and the use cases technically don't even need to live in this Next.js application. But I decided not to go down that approach just yet. I didn't want to add extra complexity with a monorepo. But again, the reason for that is if you had multiple JavaScript or TypeScript things, such as like a CLI tool or Next.js application, maybe you have an Express API. Those 3 different things can all import the use cases and persistence methods and invoke them as needed, and you kind of get this shared code base of all the business logic that's in its own package. Anyway, I'm curious to hear your thoughts. I know this video went kind of long, but let me know if you think this is over engineering, and also let me know if you think I applied clean architecture improperly to this Next.js code base. I'll put the link to this code in the description below, so feel free to go through it and critique it how you want. Other than that, that's all I got. Have a good day and happy coding.